Hello everybody. So today we will be presenting on polymorphism in Java, which is one of the core concepts of object-oriented programming. I am Rishi Pal, and along with my teammate Soumya Beda, we will walk you through this topic. In this presentation, we will cover what is polymorphism, its type, example, and its important in programming. So, what is polymorphism? Polymorphism comes from two words, poly and morph. So polymorphism literally means many forms. In Java, it refers the ability of a single method or object to behave differently depending upon the situation. In simple terms, one action can have multiple implementations. This help us make our code more flexible and powerful. So our next slide, why polymorphism is important. First, it improves the flexibility because the same codes can work in different ways. Second, increases code reusability. We won't need to write a separate code for similar actions. Make programs easier to maintain. Overall, it dynamics behavior in programs, which is very useful in real world applications. So we will be continuing to our next slide, which is types of polymorphism. In Java, Java supports two main types: compile time polymorphism and runtime polymorphism. Compile time polymorphism, also called static polymorphism, and runtime polymorphism, that is also called as dynamic polymorphism. We will now look at each of these detail with examples. So polymorphism example. So there here a remote control has a command button such as power, volume, and channel, which represents a single action or commands. The same remote can be used for different devices like TV, set-top box, or sound system. When the power button is pressed, it performs different action depending upon the devices it is connected to. For example, pressing power turns on the TV, while the same button may turn the sound system or another device. Thus, one command button performs different functions for different devices, which demonstrates the concept of polymorphism. So here is the example of method overloading. To understand polymorphism better, let us take a example. So here there is an example of method overloading. The method name add. Here the class name is maths operation. Here in data type int add, we have took two variables int a and int b. So the basic operation here we are doing sum of two numbers, return a and b. We with the help of double we can also add these two variables. Here is now another example, method overloading. So here similarly we have taken class calculator. Here we have taken two variables in int add a and b, and here we are returning a and b, and also we are int add int a b and c. Here we took three variables, and in return we have took the sum of three variables, and also similarly double add. So in main method, we have created an object for calculator c that is equal to new calculator. So the code program will print the numbers that we have took that numbers like 5, 10, and 15. And in double that, like we have took 5.5 and 2.5. So here's another example of method overriding runtime polymorphism.
Method overloading. Uh, some key features of method loading are same method name, different numbers of uh, different numbers or types of parameters occurs within the same class. It is resolved at compile time. This makes the code cleaner and easier to understand. Method overloading, overriding in runtime polymorphism. So now let's move on to runtime polymorphism. which is achieved using method overriding. Here, a subclass provides its own implementation of a method that already exists in the parent class. The method is resolved at runtime instead of compile time. So this is an example of so here is the class name animal. Void sound means that that's an object, and we want to get an output as an animal makes a sound. Then it extends that a new class is made and the class name is dog extended through animal. Dog also makes a sound that is dog barks, and then the main method. Key differences. The main difference between overloading and overriding are overloading happens at compile time, overriding at runtime. Overloading uses different parameters, overriding uses the same method signature. Overloading happens within the class, overriding involves inheritance. Understanding these differences is important for using polymorphism effectively. Real life examples. Another real life example is a payment system. A single function pay can be used for different payment methods like credit card, UPI, or cash. Even though the function name is the same, but the behavior changes based on the payment type. This is a practical use of polymorphism. Advantages and disadvantages. Advantages includes reduced code duplication, better scalability, flexibility in programs, easier debugging and maintenance. However, there are some disadvantages. Increased complexity, slight performance overhead, requires careful design, so it should be used wisely. Conclusion. To conclude, polymorphism is a fundamental concept in Java object-oriented programming. It allows one interface to perform multiple tasks, making program more effective and flexible. The two main types are method overloading and method overriding. Understanding polymorphism helps us write better and more scalable code. Thank you.